So let me continue layer one technologies like something called the point-to-point. What is the point-to-point and what is the shared media? This refers to, so far, I think this is video number 9 or such. So far, you knew devices, routers, switches, computers, as simple as that. You knew cables, okay, copper cable, fiber optic, etc. We are good. You knew connectors, now you can use connectors. So now you think that you have collected the good components to connect a computer to a switch, and the switch to a router, and the router perhaps to another computer, because now I know the devices and I know the cables and I know all the connectors, so I can connect and they should operate, give them some power. We are good. Now it comes to the type of connection. Type of connections like point-to-point or shared media are two of the most famous connections. Point-to-point is where we talk about a connection between two devices directly. Like right now, the connection between this computer and this router is called a point-to-point, where one single cable is doing the duty, one single cable is doing the job, one single cable is connecting the computer to the router. Good, lovely, goodbye, and that's it. This is what I want. But this is an annoying type of shared media where there is a broadcast in the way, there is a layer 2 device in the way between your computer and your router, and that will be a story, and that will be a mess if other devices were connected from there and there and there as well. This will be annoying. Why? Because I told you a couple of videos ago or before earlier that when a switch receives a broadcast message that I will talk about later, then it will receive it from port number 1 and it will immediately replicate and forward the same message to the other 23 ports that it has. This will be annoying. This is not point-to-point. This is a shared media. So sometimes it's not a disadvantage. Like if you have your computer would like to share something with 10 computers at the same time, then it should send a broadcast message, and you will need a broadcast shared media domain like a switch, not a router at all, because every single port of a router is a broadcast domain. So if that computer sent a broadcast message, it will be eliminated here. It will not cross the port. But if that port here sent a broadcast message to a switch, the switch will freak out saying, help, emergency, forward to everyone. It will forward to everyone. Disaster. So it will forward to all of them, and everyone will be annoyed receiving that emergency firefighting system alarm is on, etc., and it will receive all the broadcast messages. So these are the types. Now for power over Ethernet, very lovely, but not that much that you can see. Actually, I have never worked with that for the past years of networking. Why? This is mostly for IT guys and help desks. This technology says when you look to the the copper cable that has 4 pairs of copper wires, so 8 wires in matter of 4 pairs, each pair is twisted already. What we were doing actually is that we were only using 4 wires of them to send data like ones and zeros and establish that closed circuits, while the other 4 wires, we are using them to carry power, wattage, real electricity. So this is called power over Ethernet, PoE. Why there is such technology? This can carry power over two pairs of copper cables, enough to power up some network devices. Let me tell you something lovely. A wall, an access point mounted on the wall, and you need to deliver 2 things to operate this one. You need to deliver a copper cable to give it internet to this access point, and of course to connect the clients to the network, and you need to send a power cable connected to an AC adapter to operate this access point. How about no need to extend 50 power cable for 50 access point in your hotel. Only extend, let me go back a couple of times, only extend the copper cable and connect the copper cable to a Cisco switch that supports PoE. The catch is here, supports PoE, and after that we will use the 8 copper wires, 4 of them for data, 4 of them for power, and thus this will be powered on and it will start receive data. This is the idea. So this will replace the AC adapter. PoE terms are the PSE. What do I mean by a PSE? PSE is the power sourcing equipment. In that case, who is the device that is like sourcing the real generator of electricity to push it out through its ports via the copper cables, the copper wires, to reach the IP camera or the access point, etc. That will be, of course, either the switch or the power injector. So one of these guys is responsible for sourcing the power. A PD is a powered device, so a device that is making use of the power, like an IP phone, an IP camera, some PCs perhaps, etc. So these are the clients there that are making use of. The negotiations happens between the sourcing and the not the destination, the device, before and even after the supplying starts. Let me tell you something important. How much of wattage does your IP camera requires to power up? At the beginning, well, the switch will start giving too much of wattage at the beginning, and will start negotiating, like sending a 60 watt or 50 watt at the same time, and it will receive back a message saying that too much, a little bit less, too much, then a little bit less than 40, little bit less than 30, until they settle on 20 watt wattage or 20 watt to be sent only to that camera via the IP camera via port number 1 of the switch. So negotiations will happen before and even after the supply has started, until it's settled on the total amount of wattage that is stable for that PD power device to consume. Power supplying over PoE can be from 15 to 95 watts in total per switch. This depends on the switch model actually, but like let's say if some switches only support a maximum of 60 watt to be outsourced or to be sent out of their ports, and they have so many ports, then you can maybe send 5 watt per 12 ports, or like 15 watt only per 4 ports. So the total will be 60 watt only. So 5 watts or 15 watts, 30, 20, depends on your design, what you need. This is the idea. The universal power over Ethernet Plus makes use of all the 4 pair to interchangeably carry data and power. This is a technology supported on some limited devices of Cisco. It will not limit from the beginning, or it will not decide from the beginning that which pair, I'm sorry for that, I need that, I've been sitting for 5 hours, which pairs are responsible, pairs of copper cable wires are responsible for data, which other pairs are responsible for electricity. No. We will consider all of you equally, and we will treat all of you, the 8 wires, equally. I will make use of all of you and invest in all of you at the same time. If I saw 6 pairs free, not carrying data, I will push power throughout the 6 of them at the same time. If I saw only 4 available, I will use 4 or 2, depends on the availability. So this is the idea of the universal PoE plus. In that matter, sometimes it can support a high wattage or a high data and transfer rate at the same time compared to the previous types, but it's limited to some models. Okay. The last slide that I want to talk about today will be the interfaces and the cables issues, like something called collision. More than one device, like a PC, transmitting at a single time in a shared media. Well, before, when we went like 15 years ago, 20 years ago, when we used to go to that shop of that guy that connected us to a device like a hub, and all of our devices, computers connected to, and would like to play some game, football, Generals, Red Alert, or whatever Street Fighter game, whatever you remember from the 90s or early 2000s, then that guy, if that guy connected our computers via a hub, an obsolete device right nowadays, then collision will happen, because this device is considered to operate in something called one collision domain. What is that? Well, that is if and only if PC number 1 wanted to send something to PC number 2, then the hub will be busy. It will be consumed. That's it. I'm busy, don't talk to me. Okay, neglect all my other emails and meetings. I am delivering a very important message from PC1 to PC2. Shush for everyone. And when I finish that, I will go back and ask you what's next. So at that time, if like another PC, let's say 4, if PC 4 wanted to send something to PC 3, collision will happen here drop in the data of 2 to 3, not of 1 to 2, of 4 to 3, I'm sorry. So this is called collision. Later they developed bridges, and after bridges they developed switches, and with switches something called, and even with bridges actually, something called the carrier sense multi-access over collision detection. The CSMA over CD came in and it solved that issue. At that time it was the controller of separating multiple collision domains and controlling all of these collisions at the same time, delivering all the transmissions to the receivers correctly at the same time, with avoiding the collision, stopping the operations without allowing them to collide or to collision to happen, and do the tasks simultaneously of the transmission so that it will guarantee delivery at the end. Perhaps someday you will face something called layer 1 errors, like a cabling issue. Perhaps those 4 pairs are not like cabled or the other end equally. Something is wrong like that. Something is wrong like that, etc. This is called a cabling issue. Perhaps you have some hits or damages in the way for your cables. This is called a cabling issue. Perhaps you have some dirty endings with dust or whatever on the end of the LC or SC connector of a fiber optic. This must be clean so that the light will go out purely and so that it will be transmitted correctly to the other end. This is called cabling issue. Sometimes an unsupported SFP can be done. I tried to troubleshoot a connectivity between a Cisco and a Juniper routers before, like 3 years ago. On the Cisco side, I injected Cisco SFP. On the Juniper side, I injected Juniper SFP. But what happened was one of the ends was receiving laser, the other one was not. It was an MPO cable. So I disconnected one of the ends, looked to the light, and I saw the purple light. Connected that. The link is not going up. Go to the other end, disconnected, see, no light. So why? Something's wrong. So as a troubleshooting step, what I did was actually I tried to check, perhaps it's the SFP of the port. Of course, I changed the port, nothing happened. I tried to change the SFP, swap the SFPs, so Juniper and Cisco, Cisco and Juniper. One of the vendor, not both of them, but one of the vendor, I think it was Cisco, it immediately gave me a message in the router, said incompatible SFP, referring to the Juniper SFP. So I took it away. Okay, thanks for that, and continued the troubleshooting by injecting 2 Ciscos at the same time. Later I made myself stupid again, 2 Junipers at the same time. So I did multiple of things until I found out that it's not only not support an unsupported SFP. These SFPs were supported in the first scenario, but unsupported polarization type via the cable between the SFPs and the cable. In MPO, MTP over MPO, you will take the light and you will divide it to 4 different frequencies traveling at the same time. So each one of them will be called a channel with a different frequency from the other. And thus, instead of sending like 10 gigabit via cable, we will be able to send 4 10 gigabits at the same time, 40 gigabit at the same time. What happens is that the polarization of dividing the colors from red to purple, dark red to purple, that the polarization that the SFP uses on both the ends is different from the polarization that this cable can carry, and that's why the light was showing in only purple and the colors were not matching on both the ends, and it made a mess. So errors like a layer 1 errors can be cabling issue, unsupported SFP, unsupported polarization if you are at the fiber optic ward, etc. But when we go to the duplex mismatch, copper cables can send that CSMA over CD and things, can use something called half duplex, or sometimes called something called a full duplex when they communicate between 2 ends. Copper cable supports both half and full, and they must match on both the ends. When you have a problem like a link is not going up, do type show interface something, and we will do that for 100 of time in this course. But you need to make sure that both the ports, not the cables, the ports of the 2 devices, either both of them half duplex or either both of them full duplex. If it was a fiber optic connection, don't troubleshoot that, because fiber optic by default is full duplex. Okay, so one last thing, the speed must match on both the ends. Sometimes it might not. I've seen scenarios that sometimes it might not, but just make sure that you match it, because you might have another end that's not running Cisco, or Cisco obsolete device, or something that is annoying. Really sometimes troubleshooting results in very stupid results that you think that, seriously, I have invested months or years of study teaching and educating myself with really high professional troubleshooting skills, and now you tell me with a reboot it will be solved, with unplug it will be solved without changing anything, shut the interface or unshut it. Yes, sometimes things happen, believe me, things happen, why not? So even if the speed, it must match. Like if you have a speed of 10 megabit on one of the ends, make the other one as 10 as well, please. Or 100, make it 100 as well, please. If you want to manipulate some behavior, manipulate the bandwidth and the delay that we'll talk about later in chapter 3, but here do make them matching on both the ends. With these 15 minutes, I hope that you have made a good info today about this video, and I hope that you will absorb it, because in the upcoming video I will need from you a copybook, a pen or a pencil, and 100% of your attention. This will decide how good engineer you will become regarding subnetting. So have a relax. Perhaps you are at the end of a day already, don't study anymore. Tomorrow or the next day it will be a very good day to start knowing the network technologies, and go ahead with all of the layer 2, layer 3 languages there. Thanks again, and goodbye.